Hello, my name is Dr. Pierson. I am the owner of Pierson PhD Consulting. This video, it's just a short video of computer numerical control. Now I've added a little bit of history, a little bit of introduction, and some advantages of CNC. And what I'm going to do in the future is make more videos. So this is just the start of several videos that I'm going to be putting on YouTube for free. So let's take a look at some basic concepts of CNC within manufacturing. Okay, first of all, CNC, what does that stand for? Computer numerical control. So computer because it's controlled with a computer, numerical because it's using like a coordinate system to tell the equipment on the manufacturing floor with the movement of it. So it might tell it where to go on the x-axis, the y-axis, or the z-axis. And then C is for control because it's controlling it. And generally a CNC equipment is used to cut out material. It could be used to paint material. It could be used to weld material. It could be used to bend material. It's basically making some type of change to some type of part or parts within manufacturing. Now, some of the benefits of CNC, computer numerical control, is a flexibility of things being manufactured. So, and first of all, CNC equipment is pretty expensive. I mean, you can spend hundreds of thousands of dollars on one CNC piece of equipment. And so it's good to be flexible. And what I mean by the word flexible is instead of buying a machine to make one specific type of part, a CNC machine could be flexible so you can make many different type of parts with this machine. And since it's programmed, since you could put a program, you could actually use software to program it. It's almost infinite how many different types of parts you can make with a CNC piece of equipment. So it's very flexible. Okay? And also in your programming or typing in a code for CNC, it's telling the equipment how a path of the movement of the machine. So you're programming a path. Do you want it to, you're telling the machine to, follow a path to bend something, follow a path to paint something, follow a path to cut something. So you're programming in a path for the machine to make some change to a part. And how does that do that? That it does it with coded instructions. So you have to give it coded instructions. For example, how far to go in the y-axis, how far to go in the x-axis, how far to go in positive or z-axis, when to stop, when to start, how fast, how slow. So you have to, the coded instructions are what's going to tell the equipment what program path to take. Now there's manual part programming. Manual part programming is you're basically typing in what the code is going to be. You're typing in the how much it's going to move on the x, how much it's going to move on the y. So you're typing exactly the code right into the computer. Okay, so a little bit difference is computer-aided programming. Now, computer-aided programming is a little bit different, and there's a step before computer-aided programming. Generally, you're going to take a drawing, a 3D drawing from a CAD program, a computer-aided design program, and import it into another program. Another program is called computer-aided programming. And so someone designed this part in computer-aided design, and then so you have all the dimensions of this 3D or 2D object or this part, and then you're going to bring that electronically into another program, into a CAP, computer-aided program, and then you're going to, it's whatever program you bring into it, it's made, the program is designed so it could communicate with the equipment on the manufacturing floor. So then you're going to do some with things with this this program to communicate how the equipment is going to move, again, to cut something, to bend something, to paint something, to weld something, or just make some change to a part. There's also manual data input. The example of that could be using to pull out a keyboard right on the manufacturing floor and telling the computer, I want you to go so far in the x-axis, I want you to go so far in the y-axis, I want you to go so far in the z-axis. You're putting direct commands in the manufacturing shop floor. And the computer numerical control, all this is when you get into where you're programming it with software, it's called computer numerical control. Again, because it's control of the computer. It's numerical because you're using numbers, go so far in the x-axis, or so far in the y-axis, or so far in the z-axis. So, and then you're controlling it. You have some type of control. So it's called CNC, computer numerical control. Okay, a little bit of history about computer control. So in 1947, John Parsons of the Parsons Corporation began experimenting with the idea of using 3-axis curvature data to control machine tool motion for the production of aircraft components. Okay, so that's kind of how it started. And in 1949, Parsons was awarded a U.S. Air Force contract to build what was to become the first numerical control machine. And in 1951, the project was assigned by the Massachusetts Institute of Technology. In 1952, the numerical control arrived when MIT demonstrated that simultaneous 3-axis movement were possible using laboratory-built controller and a Cincinnati vertical spindle. And by 1955, after further refinement, numerical control began available to industry. Now, I don't want to get in trouble here. I'll tell you what, I took this directly out of a book, and I'm going to reference this book right now out of a Computer Numerical Control, Concepts and Programming, 4th edition by Warren S. Seamus. Okay, so I'm citing him. I think he said it a lot better than I could say it, so I just went through and took it right out of the book there. Okay, CNC machines. Okay, so there's a lot of programmable features with CNC. Now, my experience with CNC, my first job out of college, I was a manufacturing engineer, and I had the opportunity of programming punch press machines. And so we did a lot of 2D punch press machines. And it had a lot of special features on it because you wanted to, there were several things. You had to tell it, you had to use certain tooling, and you had to make sure you use statistical process control to make sure that you changed your tooling on a regular basis so it doesn't get too dull and start damaging the material or the tooling even more. And then you wanted to tell the machine how thick the material, what type of material. If you're going to bend the material, you had to tell the K factor. So there's some program features that you had to be aware of. And then I've also taught Mastercam at a place that makes military aircraft parts, and that used a whole different program of features. Okay, now in program there's things like soft wired controllers. Okay, so a soft wire controller, that means that no hardware is necessary to transfer the numerical control codes to the controller. So it's more of a software base. Okay, executive program. Basically, you have within the machine, you have what's called an executive program. Now, to tell that program exactly, that executive program, what to do, you could do two things. You could manually input, the what you want the machine to do, or you can use software. Now, the software will go to the executive program. Now, what the executive program, it's going to create code into electronic pulses, and those pulses, those electronic pulses, are what's triggering the electronics and the mechanical mechanisms within the machine on how to actually how to move. Okay, and then an executive program is in ROM. That means that if you turn the electricity off, that program is still stays within the machine. Now, NC code is in RAM. Just like on your computer, you have a ROM on a basic home computer, that it has some information like your drives, how to start up the operating system when you start up your computer. So it has a lot of what process it's going to go when you first hit the start button, all the way till you have a operating system in, all those different checks it's going to make for different hardware attached to your computer. So, but that's all hardwired. You don't want that to disappear when you turn your computer off, because then next time you turn your computer on, it won't know what to do. Same thing with a CNC machine. You want ROM to be there because when you turn on the machine, there are certain functions that it needs to do before you even have an opportunity to add a program or manually type something in. Now, numerical control code, on the other hand, if you make a program, then you take it to the executive program to control the equipment. That's only there in RAM. If you turn the power off and you don't have a battery backup, it disappears out of the at that moment, out of the whatever you're working with. It's not going to be there no more until you enter that information again. Okay, objectives of numerical control. Okay, what are some of the advantages of numerical control? It's going to enhance productivity, okay, and reduce operational expense. Okay, because you don't have someone there continuously making these parts, or cutting something, or welding something, or painting something. The machine is continuously doing it. That's going to enhance productivity. Machines can just run for hours and hours, and if you give good maintenance, if you have a good statistical process control system, if you change your tooling and do everything you're supposed to do, then the productivity and the operational expense should stay down. Now, also increases quality, because in general, if your maintenance, you have a good maintenance plan, you have a good quality assurance plan, you have good technical people operating the equipment, then you're going to get the same quality of part every time you manufacture. Increase manufacturing capacity. So that's one of if you have a punch press, generally I'm sure maybe a lot of you have seen a punch press in a manufacturing plant. You have a die that comes apart, and generally the material goes in the middle. Then the punch press comes down with very high pressure, and it makes a part. But the only thing, some of those dies that make those are thousands and thousands of dollars, and they can make parts a lot more faster. But anytime you want to add a hole or make some changes, it's not that flexible. But CNC is different. It's flexible. If you want to add another hole, if you want it to be the sides of a piece of sheet metal, you want it to be a little bigger, a little smaller, then you just go into the program and make some changes to the program, and that increases your manufacturing capacity. Reduce tool and fixture overhead, okay, because you don't have to have so many different fixtures and tooling, because a CNC machine you can manufacture many different types of parts without having many different types of fixtures and tooling, because there's so much capability within one CNC machine. Reduce setup and production time. Okay, now this video, it was just a basic video on CNC, and this video I just wanted to test out the steps of creating a video and start this video process. But please look for more of our videos. This is just hopefully this is just the beginning of a whole continuous ongoing training, and I'll be doing training in computer design. Just give you some examples: computer design, computer manufacturing, PLCs. And this was just an introduction, so other CNC videos will get more in depth, maybe some construction estimating, project planning, maybe some Excel spreadsheet, manufacturing process, statistical process control, maybe Kanban, JIT. So there's a lot that a lot of different training I plan to provide, free training on YouTube. So, and also please visit our website. It tells a little bit more about our business. And I hope you were able to take something away from this video. Thank you.